Hello students, today we'll discuss IB Physics HL paper 2, May 2019, time zone 2. In this paper you should use calculator. My name is Nariman Melim. I am located in Baku and here you can see my mobile and email. To prepare for exams, the main sources: main huge textbooks of Oxford 2014, short textbook by Tim Kirk of Oxford 2014. From examiners, it is recommended to have guide, but you should for sure have physics data booklet with formulas, because this booklet will be available for you at the exam. Let's start. So this is cover page. And we come to question 1. A student strikes a tennis ball that is initially at rest so that it leaves the racket at a speed of 64 meters per second. The ball has a mass, and the contact between the ball and the racket lasts for 25 milliseconds. A. Calculate the average force exerted by the racket on the ball. So here we have initial velocity 0, final velocity 64, mass 0,058 kilogram, time milliseconds with change into seconds. From booklet, section 2.4, momentum equals mv and force equals change of momentum divided by time, which means mv minus mu divided by time. Substituting the values and taking into account that u equals 0, we get 150 Newton, two significant figures, rounded to two significant figures. Double I. Average power delivered by the ball during the impact. Section 2.3, kinetic energy half mv squared. Note in the booklet definition of power: energy transferred by time taken for the transfer. So energy that we give is kinetic energy and time is time of contact. So we divide kinetic energy by time, and we get to two significant figures, 4.8 kilowatt. Section B. The student strikes the tennis ball at point P. The tennis ball is initially directed at an angle 7 degrees to the horizontal. The following data are available: height of net, distance to the net, and again the velocity and the angle. Okay, so it goes somehow above or through the net. Calculate the time it takes the tennis ball to reach the net. So to reach the net, first of all, we should resolve our velocity into horizontal and vertical component. Horizontal component will not change, and it will travel some distance, 11.9, with some horizontal velocity. Here we have resolution of our vector, and we see that horizontal velocity is 64 times cosine 7 degrees. Constant speed motion to the right at 64 cosine of 7 degrees meters per second. Distance traveled 11.9. Let's find, using this simple equation, velocity equals distance divided by time. Time will be distance over velocity. To three significant figures, we are getting 0.187 seconds. Shows that the tennis ball passes over net. So we need coordinate of ball when it passes above the net. X coordinate, let's call it X coordinate, or Y coordinate, doesn't matter. Actually, what is the height when ball? The question is, what is the height when ball passes the net? Let's choose the positive direction upwards. then x equals 280 plus displacement. Time we know. Initial velocity will be downward, so negative 64 sine 7 degrees, which is minus 780. Acceleration is down to also negative, minus 981. Constant acceleration downwards, section 2.1, displacement will be, we will use this formula because we don't have V. No V formula. So we substitute the values and we get the displacement will be minus 163. So coordinate will be 280 plus displacement. Displacement is negative, so we get 1.2 meters, which is well above the net. So it passes over the net. So we have shown that it passes over the net. 3i. Determine the speed of the tennis ball as it strikes the ground. Here, they actually ask velocity. They don't ask horizontal or vertical speed, they ask speed, so they ask velocity. Conservation of energy tells us that change of kinetic energy will be equal to change of potential energy. Because it falls mgh, height h, so this drop of potential energy will be equal to the increase of kinetic energy. Here actually absolute values. Rewriting for half mv squared and then making square root and multiplying by 2, we get 64.4. So this is the solution. The student models the bounce of the tennis ball to predict the angle theta at which the ball leaves the surface of a clay and the surface of a grass. The model assumes during contact with the surface the ball slides. The sliding time is the same for both surfaces. The sliding frictional force is greater for clay than grass. The normal reaction force is the same for both surfaces. Predict for the student model without any calculation whether angle theta is greater for clay surface or for grass surface. So normal force is the same, so vertical component of velocity is the same for both cases. Right. During the contact, frictional force will decrease horizontal component, but not vertical component. Horizontal will be decreased more for, here I made mistake, for clay. So for clay, greater frictional force. So here we have actually clay. And because greater frictional force, velocity, horizontal velocity will be smaller and angle will be greater. So answer is for clay greater. Question 2. A container of volume is filled with helium gas at pressure and temperature. Assume that this sample of helium behaves as an ideal gas. The mass of the helium is given. Estimate the average speed of the helium atoms in the container. So we have volume, pressure, temperature, and mass. From section 3.2, average kinetic energy equals 3.2 K Boltzmann by T. So this is for one molecule, but if we add So if we take for all molecules, this is kinetic energy of the gas. So if we take our mass and rewrite for V squared, so V will be this expression, we get the value for speed. Show that the number of helium atoms in container is so much. So we have ideal gas equation, we rewrite this for number of moles. Number of moles, on the other hand, is number of atoms by Avogadro's number. So number of atoms will be number of moles by n Avogadro. Substituting expression for number of moles and substituting known values and constants, we get 3.4 times 1020. C. A helium atom has volume so much. Calculate the ratio of volume of helium atom and volume of helium gas. Volume of helium atoms is number of atoms by volume of one atom. So then we find the ratio, and we get 5.6 times 10 minus 5. Discuss by reference to kinetic model of an ideal gas and the answers to CI whether the assumption that helium behaves as an ideal gas is justified. For an ideal gas, particles are assumed to be point objects, so very small size. Result in CI shows that volume of helium atom is negligible compared to volume of helium gas, hence assumption is justified. Question 3. The diagram shows the direction of a sound wave when traveling in a metal sheet. So it travels and then it should go closer to normal, something like this. A. Particle P in the metal sheet performs simple harmonic motion. When the displacement of P is 3.2 micrometers, the magnitude of acceleration is 7.9. Calculate the magnitude of acceleration of P when displacement is 2.3 micrometers. So this question is about simple harmonic motion. Section 9.1 tells us that acceleration is proportional to displacement. It means that ratio of acceleration to displacement is constant, actually equals omega squared. So equating ratio for the first case and second case, rewriting for acceleration of second case, we get 5.7 meters per second squared. B. The wave is incident at point Q on the metal-air boundary. The wave makes an angle of 54 degrees with a normal. The speed of sound in metal is 6010 meters per second, and the speed of sound in air is 340 meters per second. Calculate the angle between the normal and the direction of the wave in air. Section 4.4, Snell's law, linking sine of angles and speeds. Rewriting this formula for angle in the second media and substituting the values, we get 2.6 degrees. C. The frequency of sound wave in the metal is 250 Hz. Determine the wavelength on the wave in air. So frequency does not change. So in air we have the same frequency. Section 4.2 wave equation, C equals F lambda. C is speed of sound. In air it is 340 meters per second, as they mentioned. So we rewrite formula for lambda. C over F give us 101.4 meters. G. The sound wave in air in C enters a pipe that is open at both ends. The diagram shows the displacement at a particular time of the standing wave that is set up in the pipe. A particular air molecule has its equilibrium position at the point labeled M. On the diagram at time t, draw an arrow to indicate the acceleration of this molecule. According to this diagram, our particle M has been displaced to the right. And recalling that acceleration is proportional but opposite to the displacement, we draw acceleration of this point to the left. Label with letter C is the point of the a point in the pipe that is at the center of compression. So the left side moved to the let's consider this region. Here all particles move to the right. Here all particles move to the left. So they meet together, making compression. So this is why I have drawn a line here, and this is compression. Question E. Sound of frequency 2500 Hz is emitted from an aircraft that moves with speed 200 meters per second away from stationary observer. The speed of sound in still air is 340 meters per second. Calculate the frequency heard by the observer. Section 9.5. For moving source. As source is moving away, we observe red shift, so frequency should decrease. We choose equation with plus, so frequency should decrease. And putting the values, we get 1400 Hz, so frequency decreased. Wavelength measured by the observer. So section 4.2, wave equation, rewriting for wavelengths and taking into account that we have now new frequency but the same speed, we get 0.24 meters. Now we come to question 4. Question 4. Three identical light bulbs X, Y, and Z, each of resistance 4 ohm, are connected to a cell EMF of EMF 12 volts. The cell has negligible internal resistance. A. The switch S is initially open. Calculate the total power dissipated in the circuit. Because switch is open, we don't look at this part because no current flows, nothing happens here. And we have two bulbs connected in series to a battery. So they have voltage, total potential difference 12 volt equal to EMF. Section 5.2, power, we have several formulas, and because we can find total resistance of Y and Z, we choose this formula with voltage and resistance. So total resistance of two lamps in series is 4 plus 4, 8 ohm. So we put these values into the formula, substitute, and we get the answer. The switch is now closed. State without calculation why the current in the cell will increase. So if you close the switch, additional current will flow through X, and total current through battery will increase because current through Y and Z doesn't change. Or we can say that total resistance will decrease, and according to this formula, power will increase. So what I have written from Mach scheme here, a resistor is now connected in parallel, reducing the total resistance. Current through Y, Z unchanged, and additional current flows through X. I. Deduce the ratio power dissipated in Y when S is open and when S is closed. The same formula, so voltage squared over resistance. Voltage doesn't change, it is the same, equal to voltage of the battery, EMF of the battery, and total resistance doesn't change, so nothing changes, quantities doesn't change, so ratio is 1. C. The cell is used to charge a parallel plate capacitor in a vacuum. The fully charged capacitor is then connected to an ideal voltmeter. The capacitance of the capacitor is 6 microfarad and the reading of the voltmeter is 12 volt. Calculate the energy stored in the capacitor. In section 11.3 we find formula for energy of charged capacitor, and we should know that capacitor when fully charged has voltage equal to the voltage of the battery, so 12 volt. So we change microfarad into farad and we substitute values into the formula and we get 4.3 10 minus 4 joule. D. When fully charged, the space between the plates of the capacitor is filled with a dielectric with double the permittivity of a vacuum. Calculate the change in energy stored in the capacitor. So charge will not change in this situation. Section 11.3 capacitance is proportional to permittivity, so it will increase 2 times. So capacitance C2 will be 2 times greater, 12 microfarad. On the other hand, we can rewrite formula for capacitance in the form V equals Q over C. So capacitance increase, voltage decrease 2 times. As a result, it becomes 6 volt. And putting these values into the formula, new values, we get new value of energy, which is smaller. So energy will decrease by 2.1 times 10 minus 4 joules. Double I suggests in terms of conservation of energy is the cause of the above change. When we will be putting the dielectric, we will do work, and work is also always accompanied by change of energy. So it is the work done when inserting the electric into capacitor, hence part of energy turns into heat. Question 5. A proton moves along a circular path in a region of uniform magnetic field. The magnetic field is directed into the plate. Right. Label with arrow on the diagram the magnetic force F on the proton. So the force, so we should label. So this is the force. It will be to the center. So force will be to the center. So we label with letter F. Right, so this is force. Velocity V of the proton. So to find velocity, we're using Fleming-Lessons rule. So here is the picture. So close all fingers, fold all fingers, point first finger field into the paper, rotate your palm until an open thumb until it points to the center. Open second finger, it shows anti-clockwise, so anti-clockwise, and along tangent. So along tangent, we know the question was clockwise or anti-clockwise. So this is V. So we label this vector as V. So this is velocity, along tangent, anti-clockwise. Next question, B. The speed of the proton is 216 to the 6 meters per second, and magnetic field strength is 0.042 Tesla. For this proton, determine in meters the radius of circular path. Give your answer to appropriate number of significant figures. Section 5.4 tells us that magnetic force acting on charge moving with speed v in magnetic flux density B, angle 90 degrees, so sine becomes 1, Q equals QVB. On the other side, this is centripetal force for circular motion. Section 6.1 give us mv squared over r. So this is the same force written in different forms. This is why FB equals F circular. Rewriting this formula for R and substituting the values, mass will be mass of proton from the booklet. V is given. Charge will be charge of equal to charge of electron, and B is given. So we get 0.54 to 2 significant figures. Why 2 significant figures? Let me see. Because B is given to 2 significant figures. So we give answer to minimum significant figures. Here 3, here 3, and here 4. But here only 2. So minimum is 2. So we give answer to 2 significant figures. I calculate in seconds the time for one revolution. So proton is moving at constant speed in a circle. So constant speed equals distance over time. Distance will be circumference divided by one period. So period will be 2πr over v, and we get 1.6 10 minus 6 seconds. Very small time. Question 6. Deuterium undergoes fusion according to the following reaction. Identify particles X. So I have rewritten this formula, and I should balance top values and bottom values. Balancing top values, 2 plus 2 equals 3 plus A equals 1. Bottom values, 1 plus 1 equals 1 plus B equals 1. So top value and bottom value is 1. So bottom value tell us that this is hydrogen. So we have actually proton. Particle 1 H. The following data are available for binding energy per nucleon. Determine in mega electron volts the energy released. So we look to the formula. So energy 1 equals energy 2 plus released energy. Energy 1 consists of energy binding energy of 2 deuterium. So we multiply by 2. In each we have 2 nucleons, and energy of each nucleon. So we have 4.48. In the end, we have isolated proton, which has no binding energy, 0, and deuterium, which has 278 per nucleon. It has 3 nucleons, so 3 times 278 gives us 834. And as a result, the change of energy will be 386 mega electron volt. So this is negative energy. This is why energy is released. Suggest why, for the fusion reaction above to take, the temperature of the deuterium must be very high. The deuterium nuclei are positively charged and repelled. High temperature and hence high kinetic energy of deuterium are required to be able to overcome electric repulsion. C. Particle Y is produced in the collision of a proton with a cation minus in the following reaction. The quark content, so cation minus plus proton, turns into cation 0 plus cation plus unknown particles. The quark content of some of the particles involved are identified by the particle. For particle Y the charge. Charges from booklet. So section 7.3. So cation plus has structure US minus. Cation minus, so from booklet we know the charges of each of these quarks. Minus 2/3, minus 1/3 give us minus 1 for cation minus, so it has charge minus 1, plus proton. So total charge before equals 0, so it should be the same. Cation 0 has 0 charge because it consists of cation 0 consists of minus 1/3 charge and plus 1/3 charge, so 0. Cation plus 1 plus Y equals 0. So Y has charge minus 1, which is charge of electrons. Strangeness. From booklet, strangeness of S is minus 1, of anti-S is 1. Cation minus 1 equals minus 1 because only strange particle has strangeness. Cation plus has plus 1. And cation 0 has again plus 1. So strangeness before is minus 1 plus 0 equals minus 1. Strangeness after is cation plus 1, cation 0, cation plus 1, y give us -1. So y has ranges -3. Question 7. The average temperature of ocean surface water is 289 Kelvin. Ocean behaves as black body. Show that the intensity radiated by the ocean is about 400 watt-meter per squared. So formula for power emitted is given this way. So sigma is constant, T is Kelvin temperature. Power by area is intensity. Intensity radiated equals to about 400 watt per meter squared as required. Explain why some of this radiation is returned to the ocean from the atmosphere. Most of the radiation emitted by the ocean is in the infrared. This radiation is absorbed by greenhouse gases in atmosphere. The gases re-radiate partly back towards the ocean. So this is why it is returning. The intensity in B returned to the ocean is 330. The intensity of the solar radiation incident of the ocean is 170. Calculate the additional intensity that must be lost by the ocean so that the water temperature remains constant. So out we have 400 radiated plus X, which we don't know. Additional. In, it is incident on the ocean, return to the ocean. So 500 is in, 400 is out, so X 100 additional is out. Suggest the mechanism by which additional intensities can be lost, mainly evaporation. Question 8. Monochromatic coherent light is incident on two parallel slits of negligible width, a distance d apart. A screen is placed a distance from the slits. Point M is directly opposite the midpoint of the slits. Initially, the lower slit is covered, and the intensity of light at M due to the upper slit alone is 22. The lower slit is now uncovered. Deduce in watt over meter squared the intensity at M. At M, amplitude will double as constructive interference is observed. Section 4.3 tells us that intensity is proportional to square of amplitude. As amplitude increases 2 times, intensity increases 4 times and becomes 88 watt per meter squared. P is the first maximum of intensity on one side of M. The following data are available. Calculate in nanometers the wavelength of the light. So we have the following from section 4.4, the following formula for fringes appearing for double slit experiment. Fringes is distance between fringes is distance between maximums. So we rewrite this formula for lambda, and distance between fringes will be MP because first maximum is here, and all the rest is according to the formula. With substitute values we get 560 nanometers. The width of each slit is increased to so much. The rest are the same. Suggest why after this change the intensity and P will be less than at M. The interference pattern will be modulated by single slit diffraction. So we have double slit fringes, and this is modulation by single slit diffraction. Show that due to single slit diffraction, the intensity at a point on the screen a distance of 28 millimeters from M is 0. This is formula for angle between first minimum and central maximum, and B is slit width. So we calculate, we get angle in radians. Then looking at this diagram, so we should find x. X will be found from tangent. Tangent equal x by 1.5, so here 1.5 meters distance. So we find x, and we find that it is 28.0 millimeters. So change calculated to radians in mode regime. Don't forget, so this is radians. Question 9. Question 9. A. A planet of mass m is in a circular orbit around a star. The gravitational potential due to the star at the position of the planet is V. Show that the total energy of the planet is given by equation half mv. So section 10.2 give us gravitational potential. Total energy equals potential energy plus kinetic energy. Potential energy is given. Orbital speed is given. Hence, kinetic energy is half mv orbital. So it is half mgmr. It means the total will be minus half gmmr, and as this is minus gmr is v, we are getting the formula. Substituting, we get the formula. Double I. Suppose the star could contract to half its original radius without any loss of mass. Discuss the effect, if any, this has on the total energy of the planet. So here 2 points. It means that you should give answer and then justify. If we look to the formula, total energy depends only, doesn't depend on the radius of the star. So it depends on mass of the star, mass of the planet, and distance of the planet. So at the position of the planet, the potential doesn't depend on the radius of the star. The potential will not change, and so energy will not change. Okay. Next question. B. The diagram shows some of the electric field lines for two fixed charged particles, x and y. The magnitude of the charge on x is q, and the charge z on y is q, small. The distance between x and y is 0,600 meter. The distance between p and y is 0.820 meters. At p, the electric field is 0. Determine to one significant figure the ratio q over q. So potential, according to section 10.2, potential equals kqr. Field strength equals minus, and here we have to differentiate. So we get minus q r squared, or you can use gravitational Coulomb's law. Just divide by charge to get field strength. So at P, the field strength from X equals field strength from Y by absolute value. And what is different? Charges is different, and distance is. So this distance is different, and this distance is different. So rewriting formula for ratio of charges and to one significant figure. Okay, let us make it one significant figure. So to one significant figure, the ratio will be 3. Question 10. A small magnet is dropped from rest above a stationary horizontal conducting ring. The south pole of the magnet is upwards. While the magnet is moving towards the ring, A. State why the magnetic flux in the ring is increasing. Distance between magnet and the ring decreases. Magnetic flux density increases. Area is the same, so magnetic flux increases. Sketch using an arrow on diagram 2 the direction of the induced current in the ring. So, deduce the magnetic force on the magnet. Due to Lorentz law, induced current should stop motion as the magnet is approaching, hence repulsion force. So we should get repulsion force. So to decrease magnetic field of magnet, induce charge, induce magnetic field from paper. So either right hand grip rule, or we should stop approaching North Pole by this field. So current should be according to this N letter. So here should be North Pole, and current should be anti-clockwise. The magnetic force will be repulsion. Question 11. Suggest why the Broglie hypothesis is not consistent with the Bohr's conclusion that the electron's orbit in the hydrogen atom has a well-defined radius. The Broglie's hypothesis states that the electron is represented by a wave, therefore it cannot be localized at definite position, it is spread over area. B. In an experiment to determine the radius of carbon-12 nucleus, a beam of neutrons is scattered by a thin film of carbon-12. The graph shows a variation of intensity of the scattered neutrons with scattering angle. The de Broglie wavelength of the neutron is so much. Estimate using the graph the radius of carbon-12. According to section 12.2, first minimum of electron diffraction pattern around a circular orbit is given by this formula. Rewriting and substituting values, so using angle of 17 degrees, we get diameter, and then we divide diameter by 2 to get radius, so we get 2.7 times 10 minus 15. The ratio volume of nucleus of mass number A by volume of a nucleon is approximately. Comment on this observation by reference to the strong nuclear force. So we see that according to section 12.2, the radius of a nucleon equals to volume of nucleon multiplied by atomic number. It means the number of nucleons. It means that if there are no free spaces between nucleons, this implies that there is very little space in between the nucleons because the nucleon force is stronger than the electrostatic force. Next question. A pure sample of copper 64 has a mass of 22.8 kilograms. The decay constant of copper is 5.5, 10 minus 2 hours per hour. Estimate in becquerels the initial activity of the sample. So section 12.2 gives us activity with time. Lambda is given, we change into second by dividing by 3600. Number of atoms we find from Avogadro's number by dividing mass by molecular mass. Molar mass is mass number in kilograms, so we divide. So this is number of moles, and an Avogadro is how many atoms in a mole. So we divide mass by molar mass, 64 kilograms, we get the number of atoms, At time 0 activity, initial activity, it is lambda by n0, so we get activity in becquerel. Calculate in hours the time at which the activity of the sample has decreased to 1/3. So activity is given from section 12.2 by this formula. It becomes A over A0 at some time, and it becomes 1/3 at some unknown time. If we take logarithm of both sides and rewrite for time, we'll get minus logarithm 1/3 over lambda, so it will be 20 hours. This finished the paper. Thank you for your attention.